Hello everyone, welcome to Maths Club. So today we are going to do another example of how to find the volume of a solid by using the disk or washer method. But this time we are going to rotate the resin about the y-axis. So let's start with an example, and here is the example. That is, we need to find the volume of solid generated by rotating a resin bounded by the curve y is equal to y square is equal to x, lines y is equal to 1, y is equal to 3 and y-axis, and the resin is rotated about the y-axis. So first again we have to draw all the lines and the curve, and we have to identify the resin bounded between them. And then we are going to rotate that resin about y-axis to generate the solid. So let's start with x-axis and y-axis. That is x-axis and y-axis. And the curve here is y is equal to x cube, y square is equal to x. And two horizontal lines which is bounding the curve are y is equal to 1 and y is equal to 3. So this is the resin which is actually bounded by all the curves and the lines. So we are going to shade this resin first. So this is the resin bounded between curves and the lines. Now this resin is going to rotate about the y-axis. So if we rotate the resin about the y-axis, then all the lines and the curves will also going to rotate about the y-axis. So when this line y is equal to 3 rotated about the y-axis, then this will going to form a circular portion like this. And similarly, when this line y is equal to 1 rotated about the y-axis, it will again going to form a circular portions like this. Now to identify the solid, we just need to join this two part. This will form the solid here. This is the top portion, the top surface of the solid. And this is the bottom surface of the solid. Now we need to find out the volume of this solid. As like the last cases when we found out the volume of rotation about x-axis, here also to find out the volume of this solid, we have to take the cross section of the solid perpendicular to the axis of rotation. And here the axis of rotation is the y-axis. So we have to take the cross section perpendicular to the y-axis to find out the volume of the solid. So if we take perpendicular cross sections to the y-axis, it will be again a circle like this. You can shade this circle for better understanding. And after finding the volume of this circle, we can integrate it from y is equal to 1 to y is equal to 3 to find out the volume of the entire solid. So let's take a better picture for clear understanding. So here is the solid. Y is equal to 3 line created this upper circular, and y is equal to 1 create this lower circular part. And this is the disk we have talked about. Let the width of this disk, which is perpendicular to the axis of rotation, that is the y-axis, we can consider the width, which is going to be very small, as delta y. Now, first of all, we need to find out the volume of this disk. And to find out the volume, we need the area, and we can multiply the area by the width to get the volume. So here, if we look at the picture, we can see the radius of the disk, which is this portion, and the y coordinate of this point. We are taking this point as P. If the P point is your x comma y. So x comma y is a point on this curve, and here the radius of the disk r and the x coordinate of this point, that is x, will going to be equal, because both representing the distance of the point from axis of y. So when we are trying to take the area of the disk, which we can denote by delta A, as is the circular disk, so it is your pi r square. And if we replace the r by the x, this become pi x square. Now to find the volume of the disk, which we can denote by delta V. This is simply the area, the delta A, multiplied by the width, that is delta Y. Overall, it gives you pi x square into delta Y. As is the volume of this disk, so if you want to get the volume of the entire solid, we have to integrate it from the lower portion to the upper portion. And here from the figure, we can see the lower portion bounded by y is equal to 1, and the upper portion is bounded by y is equal to 3. So here, the boundary of the variable y is from 1 to 3. So finally, we can say the volume of the entire solid V become integrations of 1 to 3 delta of V. Now, in delta V, we have the delta Y, but when we convert the smaller region like delta Y into the integrals, we need to replace it by the dy. So here it is 1, 2, 3 pi x square dy. Here you can see the variable of the integral is y, whereas the other variable of the integral is x. So to integrate it, we need to convert the x into the y first. And from where you can convert, as x comma y representing this point P. So it is also lying on this curve, which we have y square is equal to x. So from here, we can replace the x by the y square. So simply we have to replace the x by the curves we have. So it's become pi y square the whole square. Where we can simplify it further by taking out the pi outside the integral. So 1 to 3 y to the power 4 dy. Now this is a very simple generalized integral where you need to use that formula which you have used before also, that is integration of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So by using this formula, we can finally write the volume as pi. Here the n is 4. So it gives you y to the power 4 plus 1 divided by 4 plus 1, and it is varying from 1 to 3. So simply we have to calculate it further. 4 plus 1 gives you 5. So we will have pi by 5, and if you put the values of the upper and the lower limit, it gives you 3 to the power 5 minus 1 to the power 5. Now simply you have to calculate the rest of the things. 3 to the power 5 will going to gives us 243, and 243 minus 1 gives us 242. So overall final answer we are getting pi by 5 into 242. So our final values of the volume comes here, that volume is equal to 242 pi whole divided by 5. So this is the volume of the solid generated by the bounded curves and line about y-axis. Hope you understand the process, and stay tuned for the next video where we are going to discuss a bit more complicated questions. Thank you. Have a nice day.